Hi there everybody, it's Bobby, your cruise director, up on the navigational bridge with Captain Rob. It's day number 5 of the cruise, just gone past 1 o'clock, and we want to give you a quick update on our weather. So I'm going to hand it straight over to the master. Captain, here we go.
Thanks, Bobby, and good afternoon, ladies and gentlemen. This is your Captain Rob, our second installment for weather forecast. I wanted to take you back in time a little bit and show you a bit of the weather system that we've been experiencing over the last few days. And this is a perfect way to show you visually just how it looks here in the North Atlantic. So here we have Spain and the Straits of Gibraltar. And this red ship is us. The yellow ship is also us, or would have been us, if we were to take the Great Circle Northern route, as I described in our last video shoot. And we, of course, have taken the southern route. So this presentation will show you in 3-hour increments how the weather evolved over that period of time up until present. And then we can look ahead in the future. So if we cycle through in 3-hour increments, you can see how the ship diverges as she heads north on the Great Circle route right into the weather system we have here. We felt the southern edge of it as we headed south to Madeira, and you can see Madeira here. And we passed Madeira this morning at about 8 o'clock in the morning, and it was at that point we turned on a more westerly heading. The weather behind us, drifting down into the northern and northwestern coast of Africa, and dissipating. And we can pause right there for a moment, the Great Circle route that takes us through the remnants of Oscar, Hurricane Oscar. You can see how it's expanded and dissipated. It's lost its concentration, but it's still a large area of low pressure. In the northern route, we would have felt the low pressure in the very beginning, as we did even when we headed south. We would have gotten a break, and at this time tomorrow, we would have been facing much heavier weather and a great groundswell that comes from that strong low pressure. So the southern route, the longer route, is the better route for this particular voyage, and it gives us a great advantage now as we head further west. You can see now the wind has come around behind us, and it's going to give us a nice push. It'll reduce the wind across the deck and make it a lot more pleasant. But this is a great visual to show just how the past and the future. And it is quite accurate. We found this program to be quite accurate. We've been using it for many years. We can cycle ahead a little bit into the extended forecast. And as we go into the extended forecast, you'll see that the accuracy starts to diminish, because the extended forecast, of course, is just that, a guess, as we head quite a bit further south than we would be if we were Great Circle. Here's Miami, actually Port Canaveral, excuse me, here. And that's it. This is sort of a comparison, of course, between the northern route and the westerly route. Along the way, as I mentioned the other day, we're going to go over the Mid-Atlantic Ridge. And that is this great mountain range that runs and splits the Atlantic in half. It runs north and south, and it's quite deep on either side. We're now in the Atlantic Basin, which is anywhere from 15,000 to 18,000 feet deep. But as you get near the Mid-Atlantic Ridge, it actually gets a little deeper before the mountain range comes up. So the mountain range itself has 25,000 feet difference from the base to the top. These are dramatically big mountains. We're going to go right over the top of them. And before we do, it's going to drop down to a depth of almost 25,000 feet. And then when we get over the very top of the Mid-Atlantic Ridge, it'll shallow up to about 3,000 feet beneath the ship before dropping down again into the deep. I think we have a few pictures of what the Mid-Atlantic Ridge actually looks like in Iceland, because it works its way up and then comes out of the ocean, and there you see it. So this explains it right here as I described it. But this is how dramatic and sharp this whole volcanic mountain range would look, sort of, if we pulled the plug on the ocean and got to take a look at it. And that's what we have, ladies and gentlemen. Therefore, the forecast as we go today, right now, we're getting a little rain showers here coming back to us, but this is going to come and it's going to go, and it'll gradually improve every day as we go. So I expect tomorrow to be just that much better than today.
Sure. Captain, we did the morning show on Channel 14 and we go through the program. We had one of our guests who wrote in and they were just asking, we feel the effects of this swell. So maybe you could talk a little bit about our stabilizers and how that works and what the difference is when the ship's rolling a little bit and pitching. How does that all work?
Good question. All of our ships, all cruise ships in general, have stabilizers. And what a stabilizer is a giant fin, and we have one on each side on this ship. And they're gyro stabilized and they articulate depending on the roll of the ship. So the gyro stabilization within the stabilizer, it senses the ship's roll and applies a certain amount of pitch or angle to the fin, just like the wing of an airplane. It creates a torque that rights the ship. And after a couple of rolls when you first put them out, the system stabilizes and it helps mitigate the roll of the ship. And the faster you go with stabilizers, the more they have an effect. We've had them out the entire voyage and probably will all the way till Port Canaveral. They do add a certain amount of drag in the water, so they slow us down a little bit. And therefore we have to increase a few RPM on the propellers to make the difference. But they do help quite a bit in mitigating the roll of the ship. And just because we have them out doesn't make the ride completely flat. It just helps reduce the speed of the roll.
Now, if you were, the other day I was watching the TV and you can see that you get a shot and it shows you the map and then you get to see it's the pool deck area, but you could see the horizon was moving. So was that just the way that the swell was catching the ship? And how does that affect? Is that called pitching when the ship does that?
Yes, we pitch and then we roll.
Okay.
And the stabilizers only help the roll.
So it doesn't help the...
It doesn't help the pitch.
And that's what we experience.
Yes, we're experiencing more of a roll than a pitch. So that's right, because the ship's shape of the hull, of course, is like this, and the stabilizers are out at a 90 degrees. They help the ship roll from rolling this way, but it won't help you this way.
And let me ask you a question, because I saw the weather front very much up to the north of us. We're feeling the effects of that with the swell just because of that?
Not necessarily. Another good question. Oftentimes when you get into the middle of the Atlantic or the Pacific or any large ocean, you're going to feel a swell from many thousands of miles away.
There's no landmass to stop that swell?
Nothing to stop it, and it'll travel thousands of miles.
Okay.
And then you'll have the locally wind-generated seas. And oftentimes you get this combination, and they're not aligned. So you can have a swell coming from the north, you can have the wind from the east, and then you can have another ground swell from a hurricane in the Caribbean coming up from the southwest. And so quite often, if you look carefully out across the sea, you can see the swell, and you can see the wind-generated waves, and you might even be able to detect the swell coming from somewhere else. So it's quite often we'll have 3 different directions of sea condition. And I would encourage anybody who's interested to take a hard look, watch it for a while, and you will see what I mean. You can detect it.
And as we progress and make our way across the Atlantic, obviously we're going to see a little bit of an increase in the temperature. Already we can see the difference from, I think, in Malaga, the temperature when we arrived in the morning. It was very chilly.
True.
And only got up to a high of about 12 Celsius.
Yep.
Celsius to Fahrenheit, what is that? I always go with double it at 30 and you roughly...
Yeah, you're in there.
Yeah.
You're in the ballpark.
So if it was 12, we're like 24 plus 30, we're around about 54 Fahrenheit, give or take.
Yes.
Yeah? So and I noticed just before we started filming here on day 5, we're already up to like 20 Celsius. So now we're 20 Celsius, at 30 we're almost at 70 Fahrenheit. And each day we should start to see that maybe increase just a little bit.
That's correct. And the further out to sea you get, the more the air temperature reflects the sea temperature. So right now we're experiencing about 70 degrees Fahrenheit or about 21 degrees Celsius. And that's about the temperature of the sea. And as we go, it'll gradually warm up.
Another question for you. Relative wind.
Yes.
What's...
Okay, we have true and we have relative. So, true wind
Yes.
is the wind if we were stopped and just drifting in the ocean, not moving,
That's the wind.
that's the true wind.
Okay.
Once we start to move,
Yes.
we induce our own felt wind.
Okay.
That's the relative wind. That's what you feel when you walk out on deck. So in other words, it might be blowing 25 knots true wind, but what you're feeling on deck could be as much as 50 knots.
Wow.
If we're going into it versus going with it. So Now as the wind comes around to the east, we're going to be going with the wind. It might be blowing 25 knots, but you'll have a 5-knot breeze across the deck.
Oh.
So big difference, relative and true.
Yeah.
Yeah.
Well, I want to thank Captain Rob for taking us through our weather update. Thanks for tuning in, and we'll see you next time on the Symphony Live. Thanks, Captain.
Thanks, everybody.